Okay. Okay, let's start. Good morning, everybody. It's 7 o'clock here on Venice Beach, 10 o'clock on the East Coast, 10 o'clock at night in China, and 4 o'clock in the afternoon in Central Europe. I'd like to welcome you to our computational design keynote presentations. We have 3 presentations today. Before we get going, I'll make 2 notices to make 2 comments. First of all, we have a call open for robotic fabrication that closes next Saturday. That's going to be the 26th of September. Also, we are recording we are uploading all our videos of all our discussions up onto our YouTube channel, including last week's very successful discussion with Sanjay Sama, Nadia Tirani, and others. As a result of the success of last week, we're going to slightly be shifting our emphasis to include more of these kind of thematic sessions. And we've already planning one on space architecture for November the 14th and so on. We will keep you informed of all that. Today, it's a great pleasure to welcome 3 highly talented architects and designers to Digital Futures. I say welcome. 2 of them have been members already. But I'd like to start with someone who is fresh, who is new. Ebtisam Mustafi, who has a PhD in architecture, is professor both in Cairo and also at Coventry University in the UK. Ebtisam is a new voice to us. I think it's wonderful that we're reaching out to her. I would like to thank Ahmed for putting us in contact with her. Ebtisam, who has a beautiful name, which means smiling, is one of the rising stars in the Middle East. She has her own practice, Encode, and she's won a number of awards. She was included in the top 50 of the most influential architects in the Middle East recently. And in 2019, she won the Egyptian State Excellence Award. I'd also like to welcome you to welcome Philippe Morrell, somebody who actually needs no introduction, certainly to the Digital Futures team. Philippe has been one of the most influential voices in the world of progressive architecture and computation over the last few years. He is the founder of EZCT Architecture and Design Research. He's also founded a 3D printing company, X3. He divides his time between Paris, where he's been teaching with Christian Girard in Paris-Marlequet, and the Bartlett School of Architecture in London. He was also part of the Digital Futures panel on AI, chaired by Matthias Del Campo. And lastly, I'd like to welcome Sumeen Ham. Sumeen Ham has been even more peripatetic in her existence. Sumeen Ham's family comes from Korea. She was educated in China at Tsinghua University. Then she moved to London to do the AADRL degree, to then work at Zahas, and now she finds herself in Sci-Arc. Sumeen, again, will be well known to the Digital Futures team. She ran a workshop in Digital Futures and was part of some panel discussions. So today we're going to try and keep to 2 hours. It's been, I know that for some of you, it's very late. For Nick Bow in Australia, it's just gone midnight. So we'll try and keep it to 2 hours. So we'll have 3 15-minute presentations, and then we'll have sort of panel discussion. So I'd like to invite Ebtisam to start off. Ebtisam, thank you.
Thank you. Let me share my screen. Is it clear?
Yeah, fantastic.
Okay, perfect. I would like first to thank you and welcome you all. It's a true pleasure and an honor to present our Encode to such a distinguished speaker and audience. I would like to take you through Encode's journey, why we started and where we stand and what we are looking up to. Encode is recently between experimentation and application as an attempt to develop the design industry and production in Egypt by linking practice, education through research and prototyping. So this is mainly what I'll be focusing on to show you how we've been trying to break the status quo in Egypt and present something is a bit different than what is conventional in an Egyptian market. In 2011, we have started Encode Studio offering innovative design and fabrication services supported by cutting-edge technologies and research tools that we can afford here in Egypt. And we established Encode in Alexandria since 2011, as I was just saying. And its team members are on an interdisciplinary team interface that adopts computational, bespoke, and innovative design and digital fabrication to offer to the Egyptian market architecture, interior architecture, and product design services. Just before I get into the work itself, I would like to introduce you to the founders of Encode. As we I'm extremely proud to be a partner to Ahmed Hussein in Palim Malakeh, and he's a PhD candidate there and an associate professor, associate architect at Encode. Also, Mohammed Zaghloul is a PhD in an architecture computational modeling at the ETH Zurich and doing his postdoctoral right now. And we three have graduated during the millennium, during the paradigm shift in thinking. As we were undergraduate students at that time, we were subjected to computer was just introduced to us just as a drafting tool. And we were so curious because when we used to check books and videos at that time, we used to be very curious about the work presented, for example, by Marcus Novak and Greg Lane, who really inspired us at that time. We wanted to understand more about the computer, about that abstract machine, not just as a drafting tool, but more as a partner in the design and decision-making process. So it was such a challenging time for us because we wanted to understand more about how things would go. And this made us, we three, start our studies, our master's and PhD studies around computational design and to know more about how a computer would go into design as a partner. We were also jealous because at that time we were in fine arts, and in fine arts you find different disciplines like painting, like sculpture, and everybody is just getting things done and making stuff. And at that time, most of our approaches was more of theory. And we were really jealous about it. And we were so inspired by a lot of work done by, we used to learn like Gaudi or Friotto, Frank Lloyd Wright, and all of these experimentation and doing things by hand. So we were really inspired by the idea and the concept of build to think and make to learn. So we said, and we decided, let's get out of it. Let's do something a bit of a challenge. So we funded Encode. We started doing our own studio and tried to initiate something a bit different than the conventional model that is being there in Egypt. We wanted Encode to start this journey between funding or starting a research and trying to apply it and challenge the conventional market, which is there in Egypt. So we were interested in topics related to computational design, mathematics, material exploration, understanding more about digital fabrication techniques and customization. And we tried to promote whatever we were trying to approach through different workshops and exhibitions. And we were trying to present a concept of design and foster innovation through technology and research and collaborative stakeholder participation. For us, design was not a noun or a synonym to style, but rather a verb of production and a problem solving to an added value and to work as a holistic business process. So what we were trying to do is just getting out of it and challenge what is unconventional, unpredictable in traditional market. Our philosophy was more to challenge the design production in Egypt and adopt different cutting-edge technologies and research, try to collaborate between education, where we present, practice, where we need to invade, and manufacturers who are very used to very traditional methods, to create an international hub of design that can thrive in today's economy. We have managed to promote whatever we were presenting at that time through different projects, exhibitions, and workshops with different universities. And we managed to get really A-class clients to believe in us and to give us the opportunity to investigate whatever challenges that we wanted to do. So we rose in a very challenging environment, a conventional one. We believed in what we do. We rejected what was static. We tried to embrace the change, tried to believe and present to the Egyptian market something a bit different. We started the studio by having different workshops, and we were trying to engage different students with us in order to explore different design ideas and trying to correlate between different pathways and like, for example, introducing music in this urban artistic installation. It's a pavilion which was introduced in Library of Alexandria, just to merge between architecture, music, and performance and mathematics to give an interactive installation for the public. We've tried to understand more about hidden geometry and try to understand more about the material. Many workshops that we've run in Alexandria, like the cellular structure workshops, more of understanding how prototyping works as a paradigm for linking teaching and research. And so these are some samples of how we worked with different scales, just to get used to and familiar to the process. We also were so interested in presenting our work in different exhibitions, whether local or international, and tackle and see how the market would absorb and understand more about how we're trying to present. We wanted to see how they would react. And the first one we did was Design as a Verb in Library of Alexandria in 2012. And it was more to introduce things, the theme was related to ornamatics, which is ornaments plus mathematics. And we wanted to present how we would develop the mashrabiyya, which is very popular Islamic feature in the Islamic architecture, and how would computer would give it more of a depth and more dynamic according to the inputs and parameters that was around it. We've then won a competition, which was design and industry competition. And we were lucky that we managed to produce a whole collection for ornamatics collection. And we tried to implement it in different product design at that time, because this is what we could get as an output. We didn't get clients at that time. So it was, for us, we needed to get things done. We needed to fabricate something to try to convince the market that we can do something different, which has different approach than what is common. And we were lucky that we have presented ornamatics in Saloni Satellite in Milan in 2013 in Egyptian booth there. And we won the golden medal in design and industry competition here in Egypt. And in 2017, it was selected one of the top 500 products that they were exhibited during the 20 years of Saloni. And since then, we have launched a whole collection for ornamatics collection, whether we tried to do it in chairs, in different screens, in felt panels, curtains, to play with the shade and shadows inside the space. We tried to present it into different products just to give a whole collection, to be able to understand more about the power of whatever we were trying to present to the Egyptian market, tried to present it in different interior spaces. And yeah, and then we, as I was just saying, we were trying to present the ideas in different exhibitions, see how people would react to it. we were also interested in prototyping, and for us, for example, one of the projects that we, though it's simple, we really like we were using it to promote the concept of experimentation of material through use of material and fabrication and assembly, and how assembly can help us reach different patterns through processes, through cutting on different laser, cutting different angles through by laser cutter, and by assembly you would reach different acoustic panels. These degrain, a collection of innovative, sustainable cardboard acoustic wall panels that create graceful features with modular panels in order to give a new, friendly, and interesting interior. So just getting into more about the material, understanding more about the power of the material. A lot of experimentation related to fabrication happens at the office, and we work with it. And at that time, we exactly weren't sure of what project would be applying it on a bigger scale. And then after some time, we get better chances to have a space where we can present such an idea and get it live to the Egyptian market. And it's really interesting to work with workers and try to develop their skills, because generally they reject anything which is unconventional, and they want to do what is common in the Egyptian market. Also, we do different internships in summer to encourage young ones to start believing in what we have been trying to promote. And we have been presenting different ideas that some of the interns that we have at the office, we pushed their idea to be further investigated, not just as a prototype, but to try to push it into more into a project, so they would see things getting more real. So we got the chance recently. We've been working with L'Oreal here in Egypt to use the potentials of coding to create mathematical spaces and design systems inspired by nature. Just one fold space unfolds millions of complex, detailed, and surprising patterns that we can try to implement in an interior space with different scales, with different materials, and start to help a client be convinced to adopt a concept like the growth that we have presented to L'Oreal. And it's a recent project that we're working on with them. It's one of the challenges, actually, because to convince a client here in Egypt, it's one of the really difficulties, how to sell your story, the budget that you have, the different, why should he invest in an idea that you're presenting, and why would he adopt something like this? So it's always very challenging, and to sell a story depending, and so we invest a lot of time in prototyping, in trying to understand more about it in order to get it out. We also presented different, like the parallel collection, maybe a bit of common, but at that time in 2012, it was challenging to get it and convince clients here in Egypt to start working with it. We pushed it even further in standard panels and cladding panels and it was exhibited in Material Lab in London. And we also have presented it in Tent London as well. And having it as a system, and we're exploring it in different scales and levels, and trying to understand more about changing the materials or the inputs and the space and so on. So just linking or understanding more about the market and the needs and the budget, and putting all of these inputs in order to get it out was a bit of challenge. Sometimes we get the same exercise, do it again and again and again, and try to push a new different concept in the same space as well. So we've always worked on trying to understand more about molds and so on. And maybe some of these examples, like the 3D Schroeder patterns that have been presented by one of our interns, and recently she joined the team of Encode. we're proud of her to present different ideas and alternatives to understand more about how coding would give us more depth and more alternatives to understand more about these acoustic panels, trying them with different materials, testing them, and so on. Another one from Encode's summer internship. We have worked with her to develop her idea and try to present a more of a folded wood paneling system with no connections. We're so looking forward to push it a bit further into a space or an architectural facade. And cryptography of nature is one of the recent projects or prototypes that we've been working on to understand more about the art of coding of nature, using the potentials of coding to create a digital nature as one space unfolds this poem, and understanding more about these surprising patterns that just rise from the coding. We have been trying to extract this collection of patterns harmonically integrated into a story to tell more about the magical beauty of nature that we can use or can reach by adopting unconventional model of a way of designing. So these are some of the outputs that have rose during our experimentation. And we've pushed it a bit further by experimenting the power of the CNC and trying to understand more about the quark as a material which doesn't need finishing. It's still ongoing project. We're still investigating more about it, as it's an unusual material here in Egypt. So it's still under investigation. And recently we've been trying to develop some of the experiment related to machine learning, big data, data crawling, as they are important factors. And nowadays, in order to understand more about informational spaces and try to inhabit them as an answer some of these questions for this informational spaces. But what we need is a good question in order to find these right answers for it. So we've been trying to investigate this data crawling in a project recently we've been working on with the SAP. And it's an ongoing project, and understanding more about the fabrication and decisions related to understanding a holistic process, from dreaming about the project, from trying to embrace and embed some of these new technologies in the process of thinking even and decision making, until we get it live and try to convince the client and make it more presentable and acceptable for the Egyptian market. We've tried it with different clients, and some decisions were been taken according to this gathering of information related to architectural spaces and decision making through computational process. Different projects that we have tried to use computational processes in order to help us in decision making related to view or to composition of elements in a space, in an urban space, understanding more about, for example, self-organizing maps, trying to help us in exploring different forms using such processes in order to be as an initiation for the concepts that we can start approaching and presenting in an Egyptian market. And yeah, and thank you so much for giving us the opportunity to present what we've been working on at Encode. And we're so looking forward to get more chances, more clients that would believe in us, and more time to explore more and invest in some research in order to push it and make it live, usable, meaningful to users here in Egypt, and maybe hopefully in outside Egypt internationally as well. And thank you so much.
Thank you, Ebtisam. That was fabulous. That was really, I believe in you. It's one of the nice things about Digital Futures. I mean, it works both ways. We try and extend information or try and disseminate information to remote parts of the world, but then we find out also what's going on there. And this is fabulous, very fresh. I mean, wonderful to see. So thank you so much. I've got a few questions. Thank you, Ahmed, for introducing her. Let's move on to Philippe Morrell, who, by contrast, needs no introduction. Welcome, Philippe.
Thanks a lot. Do you hear me well?
Yes.
Yes. Okay. Perfect. Let me share my screen. Sorry. Okay. Did it work? Fine. You should see my screen, right?
Yes. Yeah.
Yes. Okay. Perfect. Thank you. Thanks a lot. So I will. So first, thanks Neil for the introduction. Also, congratulations Neil and Philippe Yuan for this amazing initiative. Digital Futures, I think, is really changing the game at the moment. It's creating an immense resource of information on contemporary architecture, extremely well curated, and I really believe it's a game changer at some point. So yeah, I'm really happy to be part of it. I want to speak today not so much. I mean, I will show just like design experiments. I won't speak about theory very much. I will mostly go through a set of projects very quickly, because as you know, people can watch the video later. They can stop on images, etc. So we can show much more stuff than in a usual presentation when we have to present physically. So my whole work has been based on this. It's really about understanding this radical shift, which is the end of rationalism toward computationalism. This is why you will see that some of my work at some point might be considered as a kind of fundamental work. We are not producing so much, or I'm not producing so much, let's say, prototypes or things like this, but I like to believe that the one we are producing might be influential and important. So when I was a student, this was what we were working with at the very early 2000s. I was, let's say, a bit tired of that. I didn't want to work too much with those things. This is why I chose to move to some other platform, mainly Mathematica, because I really wanted to experience and to experiment the very nature of, oops, sorry, I think I killed the presentation. Oh, sorry guys. I really wanted to let's say, to address what I considered the nature of computational architecture, and I really felt the necessity to start from a blank page. So this is why ultimately we developed many different things. So what I consider design research is ultimately a kind of addition of design experiment plus entrepreneurship, including, of course, technology, software development, material research and formal research and theoretical speculation as well. But mainly I would say it's design experiment plus entrepreneurship. So in 2004, we had the chance to work on this amazing exhibition organized, curated by Frédéric Meguero, together with Zeynep Menan. So we had the chance to work on the whole set design with algorithmic methods. So it was about, let's say, designing the pattern on the floor through mathematical methods. Even if it was just a pattern, I think conceptually speaking, it was very interesting. And it was also about designing this ribbon, which is a kind of non-standard element with all the tiny sections of polycarbonate being different. So we worked on that with Mathematica, with a mathematician from Paris 7 University, working very much on the issue of pattern and surfaces, having to answer a very basic, let's say, set of constraints, basic, but still not so easy to solve. I mean, the brief was basic, but the answer was not so easy to deal with. So we produced a couple of formal output and physical outputs also based on that, like large scale component with CNC milling machine. So this was done in 2003. So I go very quickly on that, on these images. And also, personally, I kept working on the issue of the developability of surfaces, and let's say the relationship between pattern analysis and geometrical pattern and developability. So through the 2004 year. In 2004, I worked on that. It was basically my master thesis as a student. So it was called Empiricism and Objectivity, Architectural Investigation with Mathematica. So it was about dealing with Bezier geometry, B-splines, and trying to understand much more about this. So I did it myself. I didn't want to use Rhino to deal with those things, but I really wanted to go into the mathematics of it. So by the way, those are not really complex mathematical things, but I think it was interesting to deal with that because it was also a way to address those things on a more conceptual. I was lucky enough to see this work exhibited in an exhibition called Coding the World at the Centre Pompidou in 2018, along with some of my hero, let's say. So I was very happy and proud with this. So I kept working on the issue of algorithms and perceptions also. So these are experiments, and again, keeping working on the issue of patterns on surfaces, so geometric patterns, curvature analysis, and a couple of different strategies for patterning surfaces in order to get highly developable panels or ribbons. So I came up finally with an ISO Gaussian curvature patterning, which was very interesting. And as you can see here, ultimately you get this kind of pattern. It's a naturally adaptive pattern. It's a self-adaptive patterns on non-developable surfaces in order to get developable patches or ribbons, depending on how you deal with this. Also, those patches are four-sided patches, which is kind of interesting as well. So later, also with my colleagues at EZCT, Jelle Ferringer and Felix Agit, we work on this project, which was about dealing with optimization, genetic genetic algorithm-based optimization. So here is a very basic example of what you can do with a genetic algorithm, just like sorting a list of 0 and 1 in a very quick way. I mean, if you would have to do this by chance, or this would take a very huge amount of time, but with genetic algorithms, you can sort this kind of list in a fraction of a second, basically. So it was very well adapted for this chair project. It was a structural design research experiment. I can show you a very tiny movie of that. So I think it was one of the early use and early experiments of early use of topological optimization in architecture. We were not only interested in the technical issue, but also very much in the conceptual issue. We wanted to check what happens when you design a piece of furniture, obviously a canonical object in the history of architecture because it's a chair. So we wanted to see what it does if you don't give any preconceived idea or etc. Later, we kept the same approach for the COC pavilion competition that we will very quickly see later on. So here you see also a genetic algorithm optimization process regarding the quantity of light. So working on this project, we finally came out with almost a new kind of aesthetics, which now some people are considering as a kind of voxel aesthetic or a discrete component aesthetic. Personally, since I was much more interested in logics rather than in geometry, just like that. I mean, I just enjoy logics, but I'm not a big fan of geometry. I have to confess. I think it came as a kind of natural output, you know, this discrete aesthetics. But most of all, when you deal with this, I believe that you can go much deeper and that you can capture the real nature of computation, because you mostly have to deal with the presence or absence of matter with 0 and 1s. And of course, it depends on the granularity of the object. You know, you can deal with big voxels or with tiny ones or whatever. But conceptually speaking, I believe that it was a nice move towards a better understanding of the nature of computation in architecture. So we kept working on that in 2007 for the COC pavilion. So it's a project of the office. We developed different strategies, also strategies for almost like ornamental strategies for the surfaces, ornamental but also structural. So these are plans, traditional plans and sections of this pavilion and renderings as well. The project was kind of successful, so I have a very ambivalent feeling regarding this project. Conceptually speaking, I see it more as a kind of etude rather than something which is part of a long-term agenda I'm trying to develop. But still, I believe that this project has some sort of radicality and also some sort of weird elegance, because it's in between a kind of flower that could be also I don't know, a snake or something like that. It has this kind of weird aesthetics. So ultimately, this is a view of the model, of the physical model of the project. Unfortunately, it was never built. It's a bit of a pity, but it is the fate of most design experiment or competition, not to be built, actually not being built. After I went back into this voxel aesthetic, not only as an aesthetic, but also on a very practical level, I asked myself, would it be possible to build with this kind of, this kind of element or this kind of object or this kind of architecture by using discrete components rather than faking the discreteness of the object by having to add and to glue together CLT wood panels. So I came up with something which is a concept of a universal house, a house that would be made of kind of Lego block, but contrary to Lego blocks, they would be fully three-dimensional, with based on a unitary module, and this module would be perfectly regular. So this idea, or let's say this work, was born in the summer of 2007. I was just doing a bit of combinatorics just for fun and playing around with a bit of basic mathematics on the beach. And I draw a couple of these things. So being back from holiday in September, I said, okay, maybe now it's time to look at that a bit more seriously. So with a couple of young interns and with my colleagues at the office, we looked at what's called digital geometry, which is a very specific kind of discrete geometry. It's a geometry which is only based on integers, while discrete geometry, for example, it could be computational geometry, it could be whatever. It's a very generic name, but digital geometry is much more specific. So with this, we prototype at a tiny scale one self-interlocking construction, universal construction module. And finally, we came up with this, with a full construction, fully integrated construction system with panels that you only have to plug on facades, etc., etc. But this was published, I think, in 2008 or something in an issue of AP. But the problem is that with these things, when you accumulate a very large amount of voxelized component, because you multiply the interfaces, ultimately you have something which is a bit weak. It's not as stiff and as solid as you would like it to be. So at some point you have to think of a kind of reinforcement afterwards. And this is what we will see. I show you what the office was about at that time. So this is an image of the office in very early 2010. We bought at that time an robot, a tiny ABB. We also initiate the development of a plugin for Grasshopper that would allow architect and architecture students to have a much better control and a much easier control of robots directly from Grasshopper. So this is Thibault who developed this. Later on, he created his own company. So you see Thibault here. By the way, it was a bit of a mess, the office, with a laser cutter and with many many stuff, but I think it was a very interesting time. In fact, starting from this voxel construction system, we said, okay, why not trying to reinforce the voxels by pouring in fiber reinforced concrete in tiny holes? Then, in fact, we would create lattices, a fully new kind of lattices, because the fiber reinforced concrete would be poured within the insulating modules. This is what you see here with the white EPS modules, but it could be done also with wood. So we presented this work finally in 2012 at Centre Pompidou in an exhibition dedicated to computational design. This is what you see here. This is a very early example of a lattice, of a concrete lattice, which was created by pouring in fiber reinforced concrete in sand, in 3D printed sand mold. It was maybe, I don't know, but it has to be checked. But yeah, it was definitely one of the very early use of 3D printed sand molds in architecture. We didn't really manage to solve this issue of voxels. It's a very complex, very difficult, time-consuming, and let's say expensive research. We didn't have a lot of money at that time, so we said, okay, at least let's try to validate the relevance of fiber reinforced UHPC. UPC lightweight lattices. So we did this with molds. So we worked on other kind of lattices, ultimately having very little to do with the discreteness logic, which was in fact the reason for starting this research. But again, we couldn't solve all problems at once, so we had to divide different problems. So we worked on recursive lattices, which according to me would be the real shift between the, let's say, the traditional Western metaphysics, Western architecture, but also the Western metaphysics of architecture, which is ultimately not based on the absence of material, but mostly based on the presence of it. While a new metaphysics was clearly born during at the very end of the 19th century with Eiffel, as we can see here. But our ambition was not to keep working with steel. It was really about working with concrete and trying to see what can be done with radically new kind of concrete and novel kind of concrete, mainly UHPC. So we were influenced by this tradition of extreme lightweight architecture, but again, contrary to the traditional steel construction in architecture, the idea was to go toward, like, for example, 3D printing or concrete lattices. If you look at that, it's made of steel. Basically, what we wanted to do is that we just wanted to make it out of concrete. This is a famous building by Zaha. It's made of steel. And again, wanted to say, okay, let's try to do it in concrete. So we worked on the competition also for Osaka on that. And ultimately, we merged this logic with another logic, trying to rethink the use of concrete in architecture and the use of molds also in architecture. So we developed this project further, creating 3D printed sand molds. Obviously, we worked at that time. It was very interesting. Again, it was a very interesting time, very interesting collaboration, and very exciting result as well. So here are the molds. in sand. Here is a detail of the final output where you see the concrete, which was poured in 3D printed sand molds. So here is an image of that. A couple of images of the final prototypes. Just to give you an idea, there's only 34 liters of cement here. So ultimately, it's an extremely lightweight concrete construction. And I very much believe that the future of concrete construction is about extreme lightweight lattices. Later, we kept working on this, so also a couple of mathematical experiments were done, and ultimately we extended this research by making use of different techniques in order to scale it up, and hence came the creation of a company which is X3 actually. Very quickly, in the meantime, I worked on some graphic design work also, very recently for the Centre Pompidou for an exhibition about artificial intelligence in art and architecture. So I go very quickly through that because I don't have a lot of time, but I very much enjoyed this because again, it gave me a new relationship with the abstraction of computational architecture, which I believe is also a very important issue at stake at the moment, because many people are speaking about BIM, building information modeling, etc., etc. I'm not really sure that the challenge is here. I'm absolutely sure that the challenge is into something much more abstract, as the exhibition organized by Frédéric Miguero, by the way, demonstrated. Here is a virtual Rembrandt painting, and when you look at the quality, when you look at the almost a kind of exactness of what artificial intelligence is able to produce, because this is the painting on the right is a Rembrandt painting created by artificial intelligence, and when you look at the detail, it's just like insane when we think of it. So ultimately, it's clear that when we see this, it's clear that the discipline of architecture is going to change in a dramatic way and much quicker than anybody is expecting at the moment. So to end up my presentation, sorry, I go to this entrepreneurship with the initiation of a company. So the company was initiated with a couple of students, and it was financed also by myself and by EZCT, who created this setup. So here you see the EZCT setup regarding 3D printing with a couple of and ultimately I created with a couple of people this company, which obviously is now public, living its own life. We were supported also by a couple of very nice companies like Dassault System. It led us also to the creation of some interesting demonstrator, but probably the most interesting thing is that in 2012, as an architect with Marc Dalibard in the south of France, we worked also obviously with my colleague at EZCT. We work on this lattice-based column. It was really something we wanted to do. You know, I mean, all of us in 2012 we really wanted to create this, but at that time we didn't really have the possibility to do that in concrete 3D printing. So the first idea was to do it by using sand casting, because we mastered sandcasting at that moment, as I demonstrated before. But in the meantime, you know, because it was a public project and it always takes an amazing amount of time. So in the meantime, we created a 3D printing, a concrete 3D printing companies. And thanks to that, after a post-rationalization of the design, we finally were capable of 3D printing the column, and also with EZCT, as you can see here, we kept working on this issue of 3D printing until today. So yes, that's it. Thanks a lot.
Thanks, Philippe. That was tremendous. I'm blown away by the range of what you've been doing. That was fantastic. I mean, I'd love to pick up on some of those questions later on, but let's just quickly move on to Sumeen for our third presentation of today. Sumeen Han, who's now teaching at Sci-Arc. Sumeen. I think you're muted, Sumeen.
Oh, sorry. So I was like thanking you guys to invite me. I was just mentioning that. Well, anyways, I will jump into my slides. So I'm currently running a practice called Sumeen Han Design, and I'm currently also working in Sci-Arc as design faculty and robotic researcher. Previously, I was teaching at the Bartlett NAA. And my recent research is more towards the work of augmented reality and the bridge in between, bringing a more like human instinction and humanness in the computational design practices, and trying to kind of understand different or emphasizing in the human roles in digital era. And maybe to kind of frame the work that I have been, why I'm doing this, there has been a huge amount of development in digital fabrication, and has been a lot of development that focuses on the robotics and 3D printings. And most of this digital fabrication research has been for a decade very much focused on the automation in construction, such as these are very good examples of the development of 3D printed geometries, 3D printed kind of projects. And of course, also similar to what Philippe has been developing, also there are lots of also theoretical development of in this kind of ways to understand the digitization and automation, and how that can also theoretically change the way we think about the architectural design. However, although there are really important changes and developments, however, such as 3D printing or this kind of basic assembly-based logics that is very much ease for digital fabrication, robotic fabrication, they are still kind of a lack of consideration of materiality. Of course, there are lots of studies and researches has been done for 3D printings. However, many of the 3D printing techniques are a little bit of against what natural materials wants to merge or wants to assemble itself. So what I have been researching throughout the few years in the Bartlett with also Daniel Wittrick, Stefan Bassing, Ego Pantich, and Guan Li, we have been developing series of technique to really try to understand different kinds of delicacies and complexities coming from human craftsmanship that is only adaptable or only possible by explicitly using human manual crafting processes. And I just brought this project as it looks very similar in terms of the aesthetics. This project obviously is done by Benjamin Dillenberger in ETH with Michael Hensmeyer. So this was a huge 3D printed, really delicate object. And on the right is one of our student projects in it's been done a few years ago. That is actually handcrafted. Of course, it's much smaller than ETH model, but in terms of the computational processes are all generated from certain algorithmic processes, but this one is highly handcrafted and still creating similar kind of aesthetics. So this project, for example, is produced with such as like really simple method using balloons as a mold and popping it with and then hardening with a covering sleeves. And behind generative logic is some kind of agent trails that is controlled by highly controlled manner positioned repellers and attractors. So it's a kind of a combination of human top-down modeling and the generativeness coming from the computer coding. And we are extremely interested in this kind of combination that comes from the computational, inspired by the computational geometries and computational powers and aesthetics, and that can be also very meaningfully translated into one-to-one material and structure. So this was the one-to-one scaled model. We also start to populate this in digital world to see how this can be scaled up in a larger scale in such a way. So the research has been focusing on this spectrum of fabrication, a one-to-one 3D model, generative strategy in digital, and architectural speculation. And we have been developing a lot of different portfolios out of over the several years of time for dealing with different types of materials and crafting processes. And the generative method has been always the main driver for finding the forms and use the inspirations and some kind of human intuition to also understand this aesthetics into something that we can fabricate in physical world. And later on, we were kind of, I wanted to kind of really push the connectivities between this generated model, which are most of the time needs a lot of post-production, and it's kind of not very precisely there cannot have any like very traditional blueprints to really explain these geometries in order for human to produce them. So later on, we were focusing on the use of augmented reality technique to really try to bring the digital models much more precisely in the real world. So that's why we started to use this kind of technique since 2016 as the Microsoft HoloLens start to become more commercialized from that point. And after that, more and more people has been using these kind of processes. So here are some student projects. I'm gonna just scroll through really quickly. And like a few different projects really starting to deal with the assembly processes that can really talk to digital world by real-time scanning the physical assembled models in reality, and that is fed back to the digital to human eye through the augmented reality devices. So for example, we also developed these kind of stretched plastic project, which is very lightweight and delicately fabricated using augmented reality, and it was pretty straightforward and fast to fabricate this. And because of the complexity of the interlocking geometries, it's very difficult to calibrate with any robotic processes within this given time. So yeah, and this is another project showing interesting way of using heat bending and twisting the steel and trying to assemble this to kind of relook at the 3D printed bridge, for example, and then see what are the potentials of these kind of assembled materials using the augmented reality. So there was, there was the three academic projects, and then we were very lucky to have this opportunity to build this pavilion together with Hologram, really talented group of people, also with Igor from Bartlett. We kind of applied this competition for Tallinn Architecture Biennale, and we were very lucky to win it, and we accomplished this pavilion last September. And thankfully, we also got the project awards from DigitalFUTURES, and thank you very much. We also have been getting more and more awards and more attentions on online medias, and we are very humbled and happy about this. And this project, maybe let me just show you a very quick video how we developed it. So we decided to, because of the competition brief is asking us to work with wood and timber, because of the kind of traditional conditions in Tallinn. And we decided to use steam bending as a main crafting methods to construct our processes. So steam bending is actually a very traditional crafting method, but normally it requires a very expensive, very fixed geometry mold. But using this AR technology or AR method, we developed this very cheap and easy method to change the mold and very freely. So we could just place all these frames around the ground, and then kind of rack or hang the steamed wood panels on those frames. This one is showing the brackets, and all these parts can be now all these parts can be differently shaped, different curvature, different geometries, without having to calibrate different things every time. So only thing we need is, so it's very sustainable. Only thing we need to do is to just change the positions of those frames according to what you see on the holographic template or holographic guides. And it has been also assembled with AR technique. So these are some snapshots of the pavilion. It's also still standing there. We are very lucky it's Biennale, so it should stand for 2 years, but now because of Corona, we extended 1 more year, so this pavilion will stand for 3 years now. So that's probably one of the good things out of this corona outbreak. Yeah, maybe I'll just keep finishing this video until the credits before I jump to the next project. So yeah, and we had a huge team of people really helped us build this project. Yeah, and then also after this, we just recently finished the construction of this another installation, which is less of like structural, but it's a landscape festival installation. And it was I teamed up with people in South Korea with Jalen from a VR company and Yumi Lee from Seoul University. She's a landscape architect, and we kind of collaborated to propose a installation competition. And we were very surprised that we won this competition. It's in Canada, Quebec, and it's called Lattice Garden. And this was actually a traditional Metis kind of item. So we were inspired by these kind of colors. So we proposed ways to use a rope to shape the undulation and the coverage of the landscape. And luckily the juries really liked us. So we kind of got the competition. But actually, all of our communication has to be done through internet. Because of the corona outbreak, we couldn't really visit the site as we were planning before. So actually the AR kind of setup was really helpful in terms of this distance kind of communication for us. So this was our team meeting kind of Zoom. So everybody is located in different time zone. We had from London, we had from LA, we also had team from South Korea, and the site was in local Canada. So that was basically our team meeting kind of thing that we were meeting every day to revisit and review the processes. And this was the first AR model that after we designed it and we sent that to the site, to our local team, and we call her our avatar. So she was our main local kind of person that learned the AR method from scratch and didn't participate in our design team in the beginning, but she was able to manage to build this. It's also because we also introduced this online digital twins that we can actually the local team will take 360 photos and record the processes each day, and it's actually updated on each day, so we can actually review the processes. And on the right is the beam model from the original design, and on the left you can see the each day processes and we can also navigate to different days and different position on the site. So we were only able to use this kind of platform to really review the site conditions every day. So these are our fast forward. These are the site processes that we were able to check in a daily basis. although it's not real time, but at least after a day of production, we could review the work, and also it's also accessible now. And for example, like if we detect any errors, we can just screenshot and tell our local team to fix it. So it was really efficient. And from the local team's point of view, they were able to see all our design guide without too much of instruction, and they could actually see and follow the guides very precisely by using the AR kind of toolkit that we provided them. So starting also from shaping the ground, like checking the height and shaping the center, placing the center, and rolling the rope. So it's all done by the local team. Local teams are literally architectural or non-architectural students or volunteers. So for the festival, hired by the festival. So they are not skilled laborers or skilled people. They were just purely trained after our Zoom meetings and this AR guides. So we can kind of think, this couldn't be done without any of this kind of technical setup that we were using. So this is the kind of the final, like probably the one of the last day. And in this scene, you can also see the person wearing AR is also working there. So kind of really like this scene. And there are lots of nice images coming out. This is really freshly taken pictures. So I want to just scroll down your pictures. Yeah, and we were also very luckily got a grant, EPIC grant for this project. So we are going to also use this chance to develop further the software kits that we were using in this project, and we are trying to develop it more like a user-friendly version of it. Yeah, and probably just the last project that I want to show is one of our student projects done in Sci-Arc. This was a seminar proposed by Ian and Carvin from Sci-Arc. They developed an interesting application for this seminar that supports their design studio project. Their studio project is basically about using different parameters in the city to decide and generate their hotel proposals. And the program now, it's not that important. It's just the way that they developed this AR application is trying to characterize each buildings as, for example, like the umami burger is shown as hamburger characters, and actually what they developed is the way to interact and engage with these characters in real geoposition. So to interact with the AI characters that represent the actual buildings in order to get some more like in-person social kind of information from these reactions. So what this is kind of a seminar kind of proposal, but it's kind of quite provocative in terms of the way to really trying to rethink about the ways we interact with social media and the digital environment, and whether this kind of new ways of interacted or gained human kind of data might have a different result in how we gather our data in the future. So this is kind of an interesting proposal in terms of that, and I'm looking forward that this can be also, these ideas can develop further. And what they're also suggesting in these diagrams are using these collected data from very special kinds of interaction with the AI characters in digital ARCT, and these data can be translated into certain data and values that they can use for generating their own geometries. And at the end, they launched, it's actually possible to download and interact with it. If you are in downtown local area, then you can actually experience this AR app by yourself. All right, and today I showed mainly 3 projects, but I have more projects on our website, and we are very diligent to actually share our project on our website. So you can also find all our student projects and our practical projects all there. Yeah, thank you very much. That's the end of my presentation.
Thanks, Sumeen. That was fabulous. I didn't know about this recent project that you just completed. So thanks so much for showing us that. That was really great. Let's move into some questions. We have the Digital Futures Committee here as well joining me. What was so interesting, I thought, maybe I can start things off by that it was actually what the presentations today were almost impossible to categorize. I mean, it was both computational design and robotic fabrication. It was both kind of academic research and practice. It was kind of a kind of AR, kind of and reality itself. It was artificial intelligence and intelligence. It was kind of experimentation and commercial all at the same time. Very difficult to categorize. And one of the things I found kind of interesting was in the sense your geographic locations. That Ebtisam is both in Egypt and in the UK. That Philippe is both in London and Paris, and Soomeen is kind of collaborating in some virtual space with Korea and everywhere else. One of the things, though, so it's kind of in the space of in between. It was super interesting from that point of view. But one of the things I think that persists in some ways, that is one of the kind of dichotomies, or that's still sort of there, is between somewhere the center and the periphery to some extent. You know, I wanted to ask Ebtisam in particular, because I mean, we have this kind of, we've inherited this world where there have been certain centers, London and New York and LA and Paris and so on and so on and so on. And there's been the kind of periphery, and you've had this kind of like debate about there should be some more kind of regional debates going on, a kind of critical regionalism and so on. But even that is coming from the center. You know, it's from Kenneth Frampton in New York, who's kind of, and so my question is, Ebtisam, do you think we're ever going to be able to break beyond this kind of center periphery thing? Could Cairo become this kind of a cluster within a kind of a network situation, or are we always going to be bound by this kind of hierarchy? I mean, hopefully we will break through, but Ebtisam, I'd like to maybe hear some of your frustrations or otherwise about being in Egypt, and what is your relationship to the other well-known centers of architecture?
I believe there are really good opportunities for whether Egyptian architects or Middle Eastern architects and so on, but it's the problem of the healthy environment that they can really invest time and effort in order to get whatever they're thinking of or dreaming of alive. It's the problem of people would like to embrace what is traditional. They don't like change. They don't like, this is maybe the main critical point, that if we compare what is happening outside this area in comparison as what's happening in London or Paris or New York, it gives the chance to experimentation. There's funding for these ideas. We've been funding these ideas from our own pockets. So we work at the university to get anything just alive, to show it to people in order to be able to push from one level to another. But yeah, and I guess collaborating on international levels as well would give opportunities to developing countries to expose more, to give more chances to people who would like to engage in such processes and tools and techniques and lovely fabrication technologies that we've seen. So it's for example, here in Egypt, you would find machines, but they're totally with the wrong people, with the wrong sector. For example, you would find it in furniture companies doing still traditional classic furniture with the same tools. They're not even trying to start doing new stuff. They're doing the same thing that they used to do it 100 years ago, but just with a machine. And it's the same thing. There is no more, and they don't want to get out of it. So we're so looking forward to get the chance to explore more, to experiment, to put hands together in order to give more chances to this part of the world.
No, that was, yeah. I was reminded of our experience in China. Elena Manfredini constructed a pavilion in Beijing maybe 10, 15 years ago. And the thing was, there were some CNC machines in China, but they were all being used to make sort of reproduction antique furniture. So yeah. Okay, I'd like to open this up for some debate. I mean, there's so much here in terms of the material that's been laid out there. I mean, absolute fabulous presentations. I thought they went together very well as also. So maybe I'd like to invite some questions from some of the, if we also have a Bilibili live stream and a YouTube live stream. So anyone who is watching on the live stream, if they could sort of put some comments in the chat, and we can relay it to this space here. We also have our committee here today. So let's open up for some questions.
Yeah, if I may start, it's really beautiful to see all these different influences coming together in your project, and everyone has a very different approach. And I think it's really inspiring. And I was really happy to see kind of the material logic coming in. And my question is to Sumeen Ham. I think it's really interesting that you're working with human intuition and AR to kind of even bypass the common logic of language concepts to create instructions and kind of creating this feedback between humans and machines building together. And so my question to you was, when I was seeing your project, most of the time the guide is the computational model that is kind of giving correctives to the human. Is there a way, or have you thought about, or maybe you even already have it, but I couldn't see it, the kind of corrective the other way around of the human to the machine? And how are you implementing that? Is it top down, or is there even ways of, like, the grassroots of the people building, giving feedback? Maybe you can talk to that a little bit.
Yeah, thank you very much. I think that's a really good question. And in fact, some of the early student project that I was showing is kind of hinting a little bit of that idea. We are trying to have computer vision to recognize what is actually in real time assembled on the table. And then that should actually, like any errors or human-made changes should be fed back to the digital model and should have computer, like in real time, interact with and make new suggestions on top of that. So the idea, of course, is to have more intuitive real-time interaction. And we have tried, for example, different ways to sense and recognize the information that is built on the table, which from vision sensing kind of technique there has been some limitations of having it accurately scanned, the geometry being accurately scanned. Of course, we can position something and then we digitize it, and that might take a lot more time, but if that is something required, then of course we can do it. I think there is still a huge, let's say, technical kind of assignment for us is to also improve the way we let computer to recognize our real world. So I know of a lot of, for example, smart cities is all about virtualizing the cities as it is in the real world, and it also in terms of structure, like our technology is not, there is like not yet very good in sensing the real physical information yet, and I think that is another technological development and assignments that we are we should like we should also like work on. But I think there will be also improvements in terms of hardware and softwares in the future. But yes, the question is very right. It is not there yet.
Thank you.
Thank you very much.
I think it's very difficult, I can imagine. So
Yeah.
I have a reflection on Professor Neil's point and Professor Ebtisam, that we in Egypt have this kind of machines and technologies, but investors still prefer to go for classical designs. I'm working with an investor who has all of robots, CNCs, laser cutters, virtual kits, and so on, but he still prefer in producing classic furniture, French classic furniture. I don't know where the problem is, why still some people in Middle East believe in classical designs and so on, and we are in 2020. 20th century it's nearly ended and the new era will begin. I don't know if the problem is in education or it's a cultural problem, but I think these points need some investigation to know why people not started caring about technologies and its application and still believes in a classical way of doing everything, not just furniture and architecture, but it's a way of application, classical application in daily life basis. I don't know why, but it's a point to raise.
Maybe I would like to add. I think this resistance to change, yes, it is in Middle East and to a certain extent in what we know today is as global South. But I think it's also in other places too. So even if you look at the work of this philosopher Edward Said, who is criticizing this Orientalism and the way the West sees East and East sees West, I think this is to a certain extent questionable, in my opinion. The other day I was visiting the city of Groningen, where we have a work by John Haydock, the Wall House. I'm sure that many of the audience know that project. And I was sort of surprised by the way the community there, the local community, was against this project. Coming from obviously the middle of nowhere, so it was a project which was initiated by Daniel Libeskind, but the community was sort of resisting against having this piece there. So I think this resistance is to a certain extent everywhere, but what is different in, I would say, West is the fact that we are a bit more, we have more freedom to sort of showcase or show what we have done, and while still there is the media and the way we have access to information, maybe in the global South is not the way we have access now in Europeans or North American countries. So this is one thing, and I think what we are doing is sort of making a voice for this sort of not seen or unseen explorations and experiments throughout the whole world. And I think Digital Futures and organizations like this trying to advocate this freedom of speech everywhere.
Yeah, just a bit.
Yeah. Go on.
What struck me was Ahmed gave me some information on Ebtisam's sort of bio. There was a reference, surprise, for the Middle East. Now that automatically suggests there is a center somewhere from which there is an East. You know, I much prefer the phrase West Asia than the Middle East. You know, and it's something that the one is struggling to overcome. And maybe, I think it's actually Edward Said talks about Orientalism. He doesn't really talk about Occidentalism, but there is also an Occidentalism to say those in that area also kind of have a slightly deferential attitude towards the West kind of thing. And it's something that, try as we might to overcome that sort of that sort of hierarchy, it becomes more obvious. I think, the comment that's been made is when everything comes together in this way, in this world, the more you notice the differences between these different places. The challenge of trying to make things equal and egalitarian is you always face these oppositions that you can't get over.
Yeah, true.
True.
Maybe I could ask Philippe, because Philippe and I both share some interest in AI. I mean, I want to see, maybe you could just say further how you see AI infiltrating the architectural imagination. What do you think the future of AI is? We're just seeing the early beginnings of things. How do you see that as developing, and what are going to be the fundamental shifts that come about as a result of the introduction of AI into more mainstream operations?
Probably, I would say it might take different forms. AI will be used to enhance architectural creativity at some point, more or less in the same way as the introduction of modeling software did in architecture with pioneers like Greg Lynn, Bernard Cash, Cass Osterreich, Ben van Berkel, and many others. So I think it will be a kind of creativity enabler, but also, and probably the most radical consequences of AI in architecture will be, let's say, technical. I mean, by technical, I don't mean something which is only limited to like structural engineering or things like that. By technical, I mean like it will simply allow people to do much more in a much easier way. This is what I mean by technical. So technically speaking, I believe that AI will have much more consequences than anybody, or maybe not anybody, but I mean much more consequences than most people imagine. When you look at complete essays, written by AI, when you look at the amazing efficiency of GPT-3 or, like systems like that, you really believe, I mean, you say, wow, I mean, if you can achieve this level of precision, I mean, just think of automated translation. If you can achieve this quality in translation because of AI, then obviously something will radically change in architecture. So it's very difficult to say what at the very moment exactly, because it will also depend on business models. It will depend on maybe the influence and genius and creativity of a few people. Like it's easy to speak about social network, but I mean, what people should ask themselves is that, just imagine that there wouldn't be somebody like Mark Zuckerberg. Would social network as we know it be exactly the same? Then it's like believing in technological determinism, like whatever whatever should happen will happen, with or without people like Steve Jobs, Bill Gates, Mark Zuckerberg, or, you know. But another way to think of it is to say, okay, these people, they play a very important role in the direction that technology is taking. And then, of course, it introduces a lot of uncertainty, you know, because again, maybe the future of architecture will be defined by people who do not exist yet. Maybe they are not even born, but they will be the Steve Jobs or Bill Gates of computational architecture, you know. So this is why I have a kind of an ambivalent feeling, because my feeling is that I know it's going to be radical. Personally, I already have let's say a couple of ideas about what will it influence, what will AI act on, you know, in architecture, on a few specific domains. But still, again, there's a lot of openness, and I believe this openness is related to the human parameter in technological evolution, in the evolution of technology.
It's an interesting idea that the example of GPT-3, I think, is interesting because a lot of things have changed in natural language processing and even machine translation the last few years. Like, I remember I was reviewing the field maybe a year and a half ago, and everything is different. Like, state of the arts are jump everywhere, much better. But at the same time, if you go to low resource languages, for example, it's still almost a barren field. So it's really hard to find translation even to English or French or German from a low resource language, from a language that doesn't have so much data online. So I wonder if something like that, if there is a peril for something similar, if this type of approaches of sort of reproduction of data, a lot of data out there, reproducing it in architecture, like what are the sort of low resource concepts or designs or styles that will not be represented? So
yeah, I see what you mean. I would say that the revolution in architecture will be even more radical than the revolution in languages, because ultimately, I think the genericity of architecture is even bigger than the genericity of languages. I mean, we can consider architecture as a linguistic issue, and you know, it was at the very heart of postmodern analysis. But even critical regionalism, for example, is based on so-called linguistic, or let's say language-based architectural differences. But in fact, ultimately, it's just geometry and dots and lines and even pixels, you know. So I believe that it's already more generic than most languages, you know. I think the issue of translation is not as critical as what we have in natural language. So this is what I believe, and also the amount of data is amazing. You know, the amount of data we have in architecture is just like amazing, and contrary to languages, we also have an historical depth of data, because very few of us have the opportunity to see on almost on a daily basis phrases or paragraphs or pieces of languages that are 1,000 years old. I mean, most of us cannot read that. I cannot read a 1,000-year-old French, you know. But when I go to the school, I pass in front of a 1,000-year-old church. So I think also the historical depth that architecture has, which is easily available for analysis, available to analysis by computers, is radically bigger than the one we have with languages. So this is, I think it's a very, very important difference between architecture as a language. Let's say it's a language. I don't know if it's a language. Personally, I don't very much consider it as a language, but as a form of expression, at least. I think it's a very important difference between architecture as a form of expression and language or natural language as another form of expression. In natural languages, we almost have no historical depth. Again, we can't read ancient languages. Even myself, if I want to read the original version of Descartes, of the discourse of method by Descartes, I find it difficult to read the original. But being surrounded by buildings that are 500 years old happens to all of us in the world, except maybe for Americans. Also maybe people living in Tokyo. We all know that there's very, very, very few buildings which are more like 25 or even 50 or 50 years old. You see, but yeah, I think there's quite important differences between architecture and natural languages, but ultimately I believe that architecture is even more, let's say, easy or more adapted to AI-based analysis than natural languages.
Thanks. Okay, I have maybe if I can jump in a question for Sumeen. First of all, well, thanks a lot for sharing these projects with us. I mean, they are really fascinating and among the most diverse and inspiring that I've seen in recent years in the field. In particular, I found very fascinating this, let's say, reinvention of crafting techniques that are traditional, like the timber bending or this technique of using the ropes in landscape formation, of the Canadian project that you've shown us. So it seems to me that by inserting, this additional guidance, that is a sort of intelligence layer that you add through augmented reality. The fact that this intelligence, embedded in additional intelligence, is a different form of intelligence from the one that is ingrained in the traditional crafting through its own tradition. It seems that the merging is very enriching. Somehow it seems there is a contamination of different crafting logics behind, and that somehow contaminates the aesthetic language, especially when we see the details of these geometries that have this that speak these different languages. So somehow I wanted to ask you if you could maybe share a bit more about how do you select a certain traditional technique that could be augmented, or how do you study them and consider their potential augmentation?
Well, I think the latest two projects I showed, the timber one and the rope one, is really coming from the brief. So we chose the timber because of the brief asked us for timber, and we just didn't want to do like straight. We just didn't want to work with straight assemblies. That's why we naturally started to work with bending and looked at it. But there also the rope, as I was mentioning, we were inspired by this kind of like colorful fabric coming from their local traditional item. And somehow we were also like inspired by some earlier student work that we were doing. Yeah, and it's kind of a combination of all these knowledges. And it's really helpful to have developing this kind of material tests in schools. So the earlier work that I have done in Bartlett with Daniel and Stefan, that was actually helps me to like also really understand different materialities and understand their assembly logic much better. If I didn't have those knowledges, I probably couldn't come up with some kind of ideas later in this kind of quick competition stages. So I think that these like the material ideas are normally when the students start to think about them, they are starting from range of like very broad research, like starting maybe from like very simple DIY techniques for like maybe some like granny's toy making techniques, even to some gardening techniques. So it's coming from a lot of different inspiration. So it's not coming from only one source of it, but definitely testing these in academic environment with more free ideas, that is actually much more helpful to like solidify these ideas in real practices in later stage. That's why I think the bridge between academic research and practices is one of the huge importance in my practice, the structure of my practice as well. But I think it's a very helpful setup for any architectural practices. Yeah.
Can I maybe ask a follow-up question on this exact matter of connecting research and practice? I loved all the presentations, and I want to ask like all three presenters of this. And the way I think of fabrication, especially the fabrication robotics part that you all showed, and materiality is that is very practical by nature. So it's almost always has to be connected to practice, even if it's a research process, right? But I want to ask from the point of view of someone that, or from my point of view, and thinking what can be applied right now. So if we were to think, and I go back to this presentation by Peter Thiel, he used to say, like, if you want to do a business, you choose a small niche and dominate it, right? So if someone wanted to choose this niche, if you were to do it in this fabrication in the immediate future of it, what do you think would that be? What is the closest to being applied in practice successfully right now? I don't know.
Maybe can I just follow another question is, in some ways, what I found interesting was that the engagement with practice was from an experimental point of view. It seemed almost, I know that Philippe has set up his own practice in 3D printing and so on, almost as you didn't want to get too fully engaged with that sort of world of practice, because you can get caught up in a kind of banal production situation. It was almost like there was a certain distance, experimentation, but not too far kind of thing.
I'm seeing the idea of using the VR and AR is maybe very promising because it don't need a massive bulk of money as an initial momentum to start a project or something like this. I see what Sumeen Ham was very interesting. Like I was fascinated how this pavilion was done, and when she started her presentation, it is done with a lens. It is a very low budget, but it's a very fascinating outcomes. So I think the future, and within this financial crisis worldwide, maybe these kind of tools, virtual and AR and so on, will be the future. I remember what Maria Yalubina was telling me in DigitalFUTURES 2019, that the future is to invent a machine for each project, not use these huge robots at the architectural application, because it's very expensive and we don't need this much amount of money to be invested in a machine, I think.
Yeah, I have only one comment more for Okay, first of all, thank you for the presentation. Was absolutely great. But I want to say something about. I mean, I'm an obsessive with processes, and I think that the differentiation between the three ways of working, of making, is that you have different assemblages and are related with the context where you are and the way you produce what you do. I think that's the principal differences between the three presentations, even when you did it in different places as well. But I have a question about, there is something that is interesting to me, that even when you have this experimentation, you have something in common, which is that you always use the same material for your design. I don't know why the experimentations have to be always about the existence or the absence of matter, and not about the assemblages between different materials in the same project. I think this comment of Maria Jablonina, that I'm a big fan of her work, but anyway, I think that this idea that you have to design your own machine for each design could be interesting, because in a way, there is something generic about to use always the same material. I don't know if, I don't know why the last experimentations, even Sumeen Pavilion, she had like different assemblages because she used wood and she used metal to give them the form, because she's working with intuition. So that opened in a way the game to include other materials and other kind of ideas of how you assemblage, in this case, not cultural assemblage, material assemblages as well. But I don't know why, when we are doing this experimentation, we only use one material, and it's just about the existence or the absence of matter, what define the shape and what define the, yeah, almost everything in a way.
A very quick answer, maybe. I share your point, but maybe it's also because sometimes you have to reduce, you know, the amount of possibilities and also the complexity of the problem, because I mean, just like dealing with one material, sometimes it can be not so easy. So this is also why we have to make choices. So I mean, that's an easy answer, but I think it's a very pragmatic and practical answer. Or let's say, I believe that mostly it's not a matter of ideology or interest, you know. It's probably because simply we have to reduce the complexity of what we are dealing with, because maybe we don't have enough resources, we don't have enough money, we don't have enough equipment. As you know, it's not the same kind of equipment which allows you to deal with wood, with steel, with concrete, etc. So I think it's just a basic practical problem in most cases. I don't think it's a lack of interest from most architects in dealing with multiple materials. At least for me. I mean, I like multiple materials, but I cannot deal with everything. It's too costly.
Yeah, I mean, I can be very pragmatic as well, because when I have to build a building, whichever the building would be, I mean, I build my own designs, and I have to deal with this thing, no? That you have isolations, and you have like I don't know, you have to think how you put things together that are not all of the same material, and this can be even the interaction with the environment change because it's related with the kind of the envelope and the layers that you have involved in it and so on. But in this case, it's almost, when you see this is everything is open. No, there is not an idea of a shelter or anything. It's just everything is open most times. I mean, in all the presentations that I've been seeing in the last years with this kind of experimentation is what happens. So if I have to build my house with it, or if I have to do a design with this, I need to close it some parts. So I have to deal with someone who have to build it and have to put things together. And maybe you have a specialist with I don't know, work with one kind of production, or would have. I really don't know how to deal with this experimentation in that specific thing. So.
Yeah, maybe
I'm very pragmatic. That's what I want to say.
Yeah, I totally agree with you. But I think that's more like practical architectural questions. And I think when, for example, when I do an architectural project, there must be a door, window, and everything, of course. Yeah, but the beauty of this kind of pavilion and installation, and these are the opportunities that you can actually test out the pure material research and studies. So that's why I think the things that we are showing is probably like a bit distant practice project, like Neil was saying. That is a little bit of a bridge between architectural projects. So it starts from start from an interest of the material assemblage and material behavior, and using these kind of small projects to test out how this material can stand up by itself or perform as what you are experimenting for. And then this should come to architectural world, of course, in a future. And of course, we need to deal with the adjacencies and enclosures. Yeah.
Could I just, Sumeen, the comment, I mean, just this is more a comment than a question. I thought that your use of AR to overcome the kind of COVID problem was really sort of inventive. And it struck me that what's kind of interesting is that one of the sessions, in fact, we had in Digital Futures World was Aki Menges and a group talking about the problems of dealing with robotic fabrication when you can't get to deal with the robots, the physical world. But actually, robots are precisely the solution in some ways. A few years ago, I had a hernia operation, and it was done. The surgeon was one side. I was anesthetized. I knew nothing, but the surgeon was one end of the room. I was the other end of the room, and it was done remotely. And they're saying already that actually robots, because they don't get COVID, there's going to be a kind of a resurgence of robots. And I think the idea of some kind of prosthetic extension and working remotely, robotically, is something that really needs to be pushed further. But I thought that was super inventive. So thank you.
I have other reflection on Marina's idea of why we use just one material. And my question is for Professor Philippe Morrell. I had a project in UAE, and I don't know why they had this vision of concrete printing, considering the hot climate they had and the high humidity. They used to see cracks into their concrete printing. It's usually there is cracks. And my client is asking me I would like to do a 3D concrete printing, but consider we have this high heat and the concrete used to do cracks, big cracks. So my question is, how do you imagine the future of concrete printing in hot areas like Middle East and Gulf countries? And the other question is there a possibility to have a concrete sustainable version in the future or not?
I don't know if the question is for me specifically, but yeah,
you know, X3 has a branch in UAE, and this is why I'm asking you, because maybe you faced this type of problems while working in UAE.
Yeah, I mean, not personally as a researcher. A few years ago, yes, I faced this kind of problem, and you know, ultimately it was not so difficult to solve. I think those things are technical problems, and ultimately technical problems are not the difficult ones. You know, there's always there's a lot. I mean, you know, like nowadays, I would say more or less anybody can start his or her own 3D printing company. You know, the knowledge is just totally available. You simply have thousands of papers online. You have the available knowledge in chemistry, in material science, in you know, and in fact, I think the knowledge has never been as available as today. Of course, I mean, all of us know that. You know, I mean, it's not new to say something like this. But the very fact is that the company who will succeed or fail or in the future, it's not going to be because of a technical problem. It's going to be because of conceptual approaches. You know, you have millions. You literally have millions of absolutely crazy, talented scientists all over the world. You know, and by the way, more and more in countries like India, in the Middle East, in Africa. I mean, I think all people are equally smart, you know, but obviously if you don't have an access to a good school, it makes it much more difficult to develop the right kind of knowledge. And because of internet, the school has become available to all, you know. If you have a good internet connection or even a bad one, it's okay, you know. The school is available. It's a global school. It's a global invisible school, you know. Which, by the way, means also at some point the end of education, you know. I mean, it's a bit sad, but you know, my point is that nowadays, if maybe it might sound, it will sound as a very radical and provocative, almost insulting statement, maybe. But I think that if you want to become an architect, a good architect, or not only in architecture, but something I know pretty well, you better have to learn on internet, maybe thanks to DigitalFUTURES like platforms, rather than to go in 90% of the available architecture school in the world, you know. So I mean, I'm pretty sure that I won't give names, but I'm pretty sure that some schools I know, if you go there and study for 5 years, you're gonna become a really bad architect, really bad. Better learn online, alone. Better listen to the kind of discussion we have today. Watch at project from Sumeen and Ebtisam initiatives, experiments. You know, I believe that if somebody does this seriously, he or she will have all the best element and material and chance to become a good architect. So again, I would say the knowledge is available, and the technical problems are not problems anymore. That's my statement. You know, they are not problems anymore. The real issue, and this is why sometimes I have the feeling that I more or less already know which company will be successful, which company will fail, according to the people leading these companies, according to the kind of directions they are taking as strategic business directions, etc. Sometimes I have the feeling that I already know who is going to win, who is going to fail, you know, and this is not because of technical problems. It's all conceptual.
Philippe, you echoed precisely some of the discussion that was going on last week with Sanjay Sama. You know, that Areti Makopoulou came to this position. Universities are no longer content providers. You can find that on the internet. They're more kind of a kind of curiosity stimulators or something. That's the role of the professor, is to stimulate that in some way. But I've got a question, which is actually a technical question, which I want to now, Ebtisam and Ahmed are both there to ask this question, and it goes back to this kind of question of concrete, especially 3D printing concrete and so on. And that is the fact that, you know, in terms of sustainability, the real problem we have, that, I mean, Philippe Bloch often talks about this, is the fact that we're running out of sand for construction. In other words, what we have for construction, we have to use sand from a certain type of sand. So, for example, UAE is full of sand, right? But for the Burj Khalifa, they had to import the sand from Australia. And I don't know, I wanted to know whether there's been any research going on in in kind of Egypt and elsewhere about how one might begin to use desert sand in construction, because it's not, you apparently can't use it because of its I don't know.
It's very round. Sometimes it's too smooth, you know.
Yeah.
Because I mean, you need a bit, you need a lack of perfect smoothness also at some point, and you know you have to find a good balance between the mechanic adhesive effect and the chemical or let's say physical chemical adhesive effect. Yes, I believe that maybe in 10 years, maybe before that, or maybe a bit later, but at the scale of the history of construction, in any case, it's not going to be a huge amount of time. Yes, we'll be able to use the sand of the Sahara Desert or UAE or whatever. I think it's just a matter of years. I think it's again, maybe I might be a bit too optimistic, but you know, for me, it's not a theoretical scientific impossibility. You know, if you look, for example, at what kind of energy you can get from the sun, you know, from thermodynamics and all that, you know that there is something that you won't be able to attain. You know, there is a theoretical limit. Also, there is a theoretical limit in the amount of information you can send according to a specific support, you know, like electrons, photon, etc., etc. It's also valid for quantum computing, etc. So here we are speaking about fundamental theoretical limitations. I don't believe that when we speak about the impossibility to use sand, of using sand from the desert at the moment, I don't believe we are speaking about fundamental theoretical limitations. Then it's a technical problem. Then science will make progress, and maybe in 20 years, maybe before, maybe a bit later, we will have all the amount of sand that we will ever imagine in the world. We will have more sand than what we need. I mean, by more, I mean like billions of times more sand than what we will ever need.
Yeah, regarding the idea of sand, we have these old kind of projects in Egypt, in Siwa, Oasis. It is made by sand, using sand, very traditional way of building constructions. It's a hotel, but the idea, it's not related yet to digital construction techniques. It is very traditional way of building constructions. I don't know if the future is to go back again and for this traditional way of using sand in construction and so on. It's a very comfortable hotel, and it's extremely expensive per night. I don't know if the futures can use this kind of materials like they used in the past. I don't know, but it's very challenging.
How do they make it? Sorry, I mean, what is the process of construction? How do they use the sand?
Mixing sand with olives, olive oil, and some kind of olive seeds, and so on, and some, let's say, fabrics from the palm trees, and mix it together to have this kind of mixture, and then started building this hotel. It's a very expensive hotel to stay in. I never visited because night exceeds $1,000 per night. It's something like this, but it's very interesting option. If you are there is no electricity. You just stay. They have this kind of candles as a sustainable way of having or living into this hotel. And in the morning, there is some kind of solar cells to generate electricity for phones, and very low level of consumption, electricity consumption, and so on. It's an example. We had a lot of examples like this in Egypt and Middle East, but the point is it's a traditional way of construction, and it is just for hotels, not anymore for big investments. But we have this kind of research, current research. I have my friend who is a student, a PhD student with Professor Philippe Ahmed Hussein Azzet. He is working on producing this kind of forms, but with digital tools. Also, we have other one called Dr. Dina. She just got her PhD in using sand, but she's still working with traditional way of sand. So we had both these two ways. The traditional way went till now, but still the digital way is investigating.
Thanks. That was fascinating. Thank you. That was really good.
Maybe I would like to go back to this notion of revolution. I think it is not surprising that we have speakers from Paris, and like we use the word revolution many times. I think in a way we were also discussing this after the session of the future of education. We were thinking the COVID era is when it comes to education is a type of 1968 movement in architectural education. And in a way, when I see all the projects next to each other, we are sort of practicing this in a way to sort of liberate this notion of intelligence from only being artificial, and address societal aspect of applying computational design or this idea of collaborative human-robot collaboration. I think this is great. But when it comes to revolution, I think when we are facing these paradigm shifts, I think the role of, in a way, ethics becomes really crucial, because when there is a radical shift, we can witness two scenarios. Like really unethical, impolite people are taking over and driving the industry, and they are not really responding to the challenges. For instance, Revit says, no, our platform is great, and this is the way it needs to be. Or do we really need to think about the ethics of computation or artificial intelligence? For instance, if I see the work of Ebtisam, should we be able to say no to many things, and if yes, how? So this is the question that I have from all the presenters in a way. Ebtisam, I would like to hear your reflection.
Yeah, I mean, very quickly, I believe that most of us were discussing, or maybe all of us were discussing here today, are people who say no much more often than the usual architects.
Yeah.
By much more often, I would say like hundreds of times more often.
But how can we turn this no's into yes in order to have an impact? No.
Maybe by creating companies, maybe by maybe just transforming research. This is why when I spoke about design research as something which is about design experiment and entrepreneurship, maybe my feeling is that far too often design research is considered as design experiment. Only the first half of the equation or of the sum is taken into account. I think design research is more than that. I think design research is a design experiment associated with entrepreneurship. This is what architects are traditionally doing. I mean, probably architects we are mostly interested in, I mean, even people like Ben van Berkel and all these kind of architects, they were doing theory, design research, but they also had a company, I mean, UN Studio. So I think today, nowadays, we should have maybe both companies, but also startup acting in the construction industry and many other things, you know, like also what Soomeen is doing with VR might, and I hope so, might definitely lead to some very interesting company which will make this technology available to more and more architects, for example. I think that would be amazing. So the difference between pure academia and design research, according to me, that design research is embedded into the real world. While academia is just about writing papers. Okay, I have nothing against papers, but I think we don't live in a world where papers alone are acceptable. They are of no use, you know, like, I mean, nobody's interested in the H index of such or such an academics, you know. Who cares, you know? I mean,
we have people with higher H index of Einstein.
Yeah, Mark Zuckerberg didn't even graduate, you know, Bill Gates didn't graduate, and you know, when he left the university to create
so we
Microsoft,
took the wrong way. We have the wrong decision.
I don't know, but what I mean is that when Bill Gates left Harvard, you know, as a very promising computer scientist, one of the most important theoretical computer scientists in America at that moment said, "Oh, it's going to be a big loss for American research." Okay, but it was a big win for humanity, you know. So you see what I mean? I believe that everything is now upside down. I believe that, and this is, for example, in my own country, in France, this is what is killing this country. We have academics that are interested in H index. Okay, but I mean the very first 3D printed piece the very first piece of concrete 3D printing in France, it came from a very tiny group of people with no money, with nothing. It didn't came from people with high H index and receiving millions from the construction industry.
But okay, Philippe, wasn't it Berocos Neves collaborating with Francois Roche who did the first 3D printed something? And I guess my point is this: I completely agree with you on this thing about indices and so on. But what is interesting about all three of you is that you use a kind of academic platform in order to test out ideas. And so what was interesting, particularly Sumeen's presentation, there was a kind of blurring between the kind of her work and her students' work. I mean, you also find that actually with the kind of with Patrick and the ADRL and the Zahar office. And I think in some ways, what academia does offer is the kind of space of opportunity to think and explore as a kind of platform, and not to be caught up in kind of everyday production. I mean, I think that, you know, to my mind, that's what made Carlos Scarpa so interesting. He didn't keep on churning out things like, you know, Daniel Libeskind keeps churning out the same kind of stuff, but did a few projects and a step back. You know, wasn't financially obligated to have to produce. And I think there is a role for academia as a kind of space of contemplation, of interaction, where you can explore ideas that then can be fed in. So, Ebtisam, I would like to hear what you think about this.
Trying to say something, but just to add on what Philippe was saying, it's about to get your hands dirty. It's about to try stuff, understand it, understand what's being positive about it. Like, for example, the data crawling example, we couldn't have managed to convince the client if we haven't been positive about it and trying stuff and trying to approach the client. We're in a stage of revolutionary stage. So it's about trying stuff and trying to understand and trying to experiment, because there is, especially maybe in where we live, there is this big gap between what's happening in the academia and the application. So it's as if you're giving testing, it's as if you're giving small portions and trying to understand and trying to reflect. And telling the story and convincing the story of what you're trying to sell to your client is extremely important, because you can do really excellent research and it's really of a very interesting process, but he would never buy it from you. So how can you find this door, or how can you find this blue door where you can really invade and try to promote your idea in the market? It's a challenge, actually. So we were standing in a position is either we stand and keep on looking, keep on enjoying other people doing stuff, or we try to tackle some parts of it and try to then reflect on it and stand and see where we stand, what needs to be changed. And this is what we are trying to hopefully would break in the coming period of time. And this is, if you see our work, you would find it going back and forth, because we're trying to see how things are going in the market and so on. So it's this gray part between the research period and the application part is really needs investigation more, maybe needs more tackling. But yeah, I'm sure there is nothing like wrong about it or no about it, instead of just being positive towards stuff that you can do, reflect and evaluate, and then learn from your experiences and keep on going further. And this is what is humanity all about.
If I may add to this idea, I think at least from my experience in university, because we mentioned also the education, I feel that this gap between research and practice has been kind of dialectically becoming bigger the more the education has become specialized. In a way, like the more we focused on education to create kind of professionals that can know how to do certain tasks, the bigger this gap, I think, became. And I remember like my own university was a bit of ivory tower style, like a bit slower, many courses, many laboratories, but also it gave this time to think and reflect. And I think this is like what I see from your projects. I saw that time there, that sort of like artistry and, effort that is required. I don't have the translation for the Greek word I have in mind, like a sort of passion, right? And that takes time. So this I think is lacking a lot in current education, and of course, practice. Also, time is quite dilated.
Add also one more comment. I think definitely we need more people like Ebtisam, to push the market and invade it. But I think also what's important is to really educate the general public about the importance of this kind of agenda. And if you think a lot of let's say, popular cultures and popular Instagram influencers, most of the cultures are not about architecture, it's about music or food or cooking. I think there has to be some kind of understanding of the culture and the invade on that. And from the educational point of view, I think that might be something that DigitalFUTURES is already doing. It's a great start, but I think we need more a larger audiences to know about what we are doing.
We need a digital spring, maybe.
We're trying. This has been a fantastic conversation. Thank you so much.
Thanks.
I really enjoyed it. I really enjoyed the work, and the icing on the cake was finding out about Ebtisam's work. And I think if we can use this platform to open up this debate beyond the usual suspects, this is going to be a fantastic contribution. But already it's kind of something is emerging in an interesting kind of way. I kind of think that we're getting history in the making with what we're trying to do here. I don't know what we're trying to do. I know what it's going to go to, but I think I share many of Philippe's kind of criticisms of the world as it is, and we have to evolve. We have to sort of move forward, and I think something new is appearing. So it's a shame to have to wrap up, but it's not wrapping up, because I think it's clear that there is a debate that is emerging, and it needs to go on, and we will have further sessions where we will try and take this further. But I just want to thank the three presenters today, Ebtisam, Philippe, and Sumeen. Fabulous, fabulous presentations. It'll be uploaded onto our YouTube platform, and every single week we'll be having a Saturday session like this. So Thank you, everybody.
Thank you.
Thanks
so much.
a lot. Thanks, guys.
Thank you.
Thanks, everyone.
Thank you for inviting.
It's nice.
Thank you.
Thank you.
Bye-bye. Thanks a lot.
Good day.
Have a nice day. Bye-bye.